close your eyes gently. Take a deep breath and let your mind travel beyond the stars to the realms of the galaxies. When we look at the night sky on a moonless night, far from the city lights, we can glimpse something extraordinary. A pale, hazy band cutting across the sky from horizon to horizon. It's the Milky Way, our own galaxy seen from within. But it's not alone in this cosmic vastness. There's a neighbor, a giant cousin waiting in the shadows of deep space. Andromeda is the closest spiral galaxy to the Milky Way, floating just 2.5 million light-years away. In cosmic terms, that's practically next door. It's our closest neighbor in the vast ocean of space, an island of stars so large and majestic that it makes our own galaxy seem modest in comparison. And Andromeda is truly impressive. It's twice the size of the Milky Way, a giant containing about 1 trillion stars. Think about that. 1 trillion suns, each potentially with its own planets, its own stories, all spinning together in a cosmic dance that lasts billions of years. It's a stellar city of almost incomprehensible proportions. But there is something about Andromeda that should capture your attention. Something that intimately connects us with this distant neighbor. It is approaching our galaxy. Not slowly, not hesitantly, but at 110 kilometers per second. With each passing second, with each beat of your heart as you rest, Andromeda moves more than 100 kilometers toward us. A collision is not only possible, it is inevitable. But don't worry. This cosmic collision will only occur in 4.5 billion years, a future so distant that the Sun will have already become a red giant, and Earth, if it still exists, will be unrecognizable. And when it happens, when these two galactic titans finally meet, they won't simply destroy each other. Instead, they will dance, slowly merging over millions of years, forming a new galaxy that astronomers have already affectionately nicknamed Milkomeda, a fusion of the names Milky Way and Andromeda. Andromeda is no stranger to this type of cosmic encounter. Studies show that it has already collided with and absorbed at least 2 smaller galaxies in the past. These galaxies were torn apart by Andromeda's gravity, their stars ripped away and incorporated into the larger structure, like rivers flowing into the ocean. It's a reminder that in the cosmos, large structures grow by devouring smaller ones, a process of building through destruction that happens on unimaginable timescales. And at the heart of Andromeda, as at the heart of almost every large galaxy, lies a dark secret. A supermassive black hole. This gravitational monster contains millions of times the mass of our Sun, compressed into a region of space smaller than our solar system. It rules the center of the galaxy, its immense gravity holding billions of stars in orbit around it. A dark throne at the center of an empire of light. But perhaps the most impressive thing about Andromeda is that you can see it. If you find yourself in a truly dark place, far from the light pollution of cities, and look at the constellation Andromeda in the autumn sky, you will see a pale, diffuse patch. That is Andromeda, bright enough to be seen with the naked eye even though it is millions of light years away. It is the most distant object that the human eye can perceive without the aid of instruments, a visual bridge across the cosmic abyss. But Andromeda is not a perfect symmetrical spiral. Its shape is slightly distorted, pulled and molded by gravitational interactions with its own satellite galaxies. It's as if invisible forces are constantly stretching and shaping its structure, creating subtle asymmetries that tell the story of past gravitational encounters. And she is not alone. The galaxy has more than 20 known satellites, small galaxies that orbit around her like moons orbiting a planet. Among them are M32 and M110, two well-studied companion galaxies, trapped in eternal orbits around their larger mistress. They are like villages around a large city, gravitationally connected, but maintaining their own identities. There's something curious about Andromeda, though. Despite being twice the size of the Milky Way and containing far more stars, it produces only half the number of new stars that our galaxy forms today. It's as if Andromeda is in a calmer phase of its life, its turbulent youth of star formation having passed, while the Milky Way still maintains a more vigorous pace of star creation. It's a reminder that galaxies, like stars, have their own life stages. And Andromeda is just the beginning of the story. It is a perfect example of what galaxies are: giant cosmic cities, containing millions to trillions of stars, each an island of light floating in the dark ocean of intergalactic space. They are the largest coherent structures in the universe, complex systems where billions of stars, planets, nebulae, and more exist together, held together by gravity in structures that can last trillions of years. And at the heart of most of these stellar cities, hidden in their centers, lies a common secret. Most galaxies possess a supermassive black hole at their core. These gravitational titans can have millions or even billions of times the mass of the Sun, and appear to be a fundamental part of galactic architecture. It's as if each galaxy needs this central anchor of intense gravity to maintain its structure throughout the ages. Galaxies come in different shapes and personalities. There are 4 basic types that astronomers recognize: spirals like the Milky Way and Andromeda with their elegant coiled arms, ellipticals, which are more like balls of stars without a clear spiral structure, irregulars, which don't fit into any defined pattern, often the result of galactic collisions, and lenticulars, which lie somewhere between spirals and ellipticals, having a disk but no prominent spiral arms. And these galaxies don't remain still in space like static paintings. They are all in motion, pulled by the gravity of other galaxies, of clusters, of even larger structures. It's a gravitational dance on a truly cosmic scale, with entire galaxies gliding through space at hundreds of kilometers per second, following orbits that can take billions of years to complete. And just as stars tend to form clusters, galaxies also group together. They can form small groups, larger clusters with hundreds of galaxies, and even superclusters containing thousands of them, all bound together by gravity in increasingly larger hierarchical structures. It's as if the universe likes to organize things into ever grander levels of complexity. Our own Milky Way is part of a modest group called the Local Group, containing about 54 known galaxies. It's a relatively quiet cosmic neighborhood, dominated by 2 large spirals, the Milky Way and Andromeda, with dozens of smaller galaxies orbiting around them as satellites. It's our local cosmic address, our neighborhood in the universe. And in these groups and clusters, something dramatic often happens. Many galaxies devour others in a process that astronomers aptly call galactic cannibalism. Larger galaxies can destroy and absorb smaller galaxies that get too close, tearing them apart with gravitational tidal forces and incorporating their stars. It's brutal, but that's how large galaxies grow over cosmic time. and some galaxies become veritable monsters through this process. Giant elliptical galaxies, often found in the centers of large clusters, can be 10 times more massive than the Milky Way. They are titans that have grown through countless mergers over billions of years, accumulating more and more matter until they became some of the largest individual structures in the universe. But the farther we look into space, the farther we look back in time. Light takes time to travel, so when we observe distant galaxies, we are seeing them as they were in the past. The most distant galaxy ever observed is 13,400,000,000 light-years away. This means that the light we see from it today left that galaxy when the universe was only about 400 million years old, a tiny fraction of its current age. We are literally looking back in time, seeing the universe in its infancy. And how many galaxies are out there? The numbers are so large that we can barely process them. It is estimated that there are more than 2 trillion galaxies in the observable universe. 2 trillion. And each one contains millions, billions, or even trillions of stars. And that number may increase as our telescopes become more powerful and are able to see even more distant and faint galaxies. It is a vastness that defies comprehension. 2 trillion galaxies, each a city of stars, each star potentially with planets, each planet with its own stories. And all of this floating in the cosmic void, connected by gravity in a web of structure and movement that extends to the limits of the observable universe. And while you rest now, consider this. You are on a planet orbiting a star in a galaxy of hundreds of billions of stars, which is part of a group of galaxies, in a supercluster, in a universe containing trillions of other galaxies. Each one a world of its own, each with its own story of birth, evolution, and eventual destiny. It is simultaneously humbling and profoundly inspiring. And there's something else that should fascinate you while you lie comfortably. Galaxies aren't stationary in space like paintings fixed to a wall. They all move through the cosmos at truly incredible speeds, gliding through the void on journeys that began billions of years ago and will continue for billions more. Our own Milky Way, that cosmic home that contains everything we know, travels at about 600 kilometers per second relative to the cosmic microwave background. That primordial radiation left over from the Big Bang that permeates the entire universe. 600 kilometers every second. Think about that for a moment. With every beat of your heart, with every gentle breath as you relax, our entire galaxy moves more than 600 kilometers through space. This means that with each passing second, we travel the distance of an entire city without any sensation of movement. There is no cosmic wind hitting our faces, no feeling of speed, no vibration or turbulence. The movement is so smooth, so completely imperceptible that it is impossible to feel. And yet, we are all on an epic journey through the cosmos, silent passengers on a galactic ship that never stops. But where are we going? What is pulling us through space with such determination? Galaxies are drawn to giant structures called superclusters, immense concentrations of matter and gravity that organize the universe on its grandest scale. It's as if they were deep gravitational valleys in the fabric of space-time, and all the surrounding galaxies are slowly rolling toward the bottom of these valleys. And our supercluster has a beautiful and fitting name, Laniakea, which means immense sky in Hawaiian, It's a structure so vast that it contains over 100,000 galaxies, spread across 500 million light-years. Imagine 500 million light-years across, a cosmic realm so large that light, traveling at the maximum possible speed in the universe, would take 500 million years just to cross it from one side to the other. Within this vast expanse called Laniakea, the Milky Way is part of a smaller, more intimate group. The local group contains more than 50 known galaxies, a small cosmic neighborhood where everyone is gravitationally connected. It is our immediate community in the cosmos, a collection of galaxies that share intertwined destinies. Among these neighboring galaxies, two stand out for observers in the southern hemisphere: the Large and Small Magellanic Clouds, visible to the naked eye as hazy patches in the night sky. These are dwarf satellite galaxies of the Milky Way, small companions that orbit our galaxy like moons orbit a planet. Indigenous peoples of the southern hemisphere have known of them for millennia, and today we know that they are our closest neighbors, caught in an eternal gravitational dance around our galaxy. And here's something fascinating. Most galaxies in the universe aren't impressive giants like Andromeda or the Milky Way. In fact, the vast majority are dwarf galaxies, small, faint, and incredibly difficult to detect. They are ordinary galaxies, the average citizens of the cosmos, each containing perhaps a few million or billion stars instead of hundreds of billions. But don't be fooled by their modest size. These dwarf galaxies can be surprisingly aggressive. They can bite larger galaxies, tearing stars apart through violent gravitational interactions when they pass too close. It's like cosmic piranhas, small but capable of ripping chunks out of much larger prey. And our own Milky Way has a cannibalistic past. Studies show that it has absorbed numerous dwarf galaxies over billions of years, tearing them apart with gravitational tidal forces and incorporating their stars into its own structure. These sacrificed galaxies leave traces, streams of stars that can still be detected today, like scars reminding us of ancient encounters. In fact, many dwarf galaxies orbit larger galaxies just like small cosmic satellites. It's a common pattern in the universe. Large galaxies accumulate a retinue of smaller companions around them, all held together by gravity in orbits that can last trillions of years. The Milky Way has dozens of these satellites, some well known like the Magellanic Clouds, others so faint that they were only recently discovered with powerful telescopes. And some of these dwarf galaxies no longer have a recognizable, defined shape. They have been stretched, pulled, distorted by the gravity of larger galaxies until they appear more like streams of stars than galaxies proper. They are like galactic ghosts, the elongated remnants of what were once coherent structures, now scattered in bands along their orbits. When galaxies collide, something interesting happens. Despite the drama and epic scale of the event, individual stars rarely collide with each other. Why? Because the space between stars, even within galaxies, is so vast that the probability of two stars actually colliding is minuscule. They simply pass each other like two swarms of bees interpenetrating. But gas clouds are another story. They always collide when galaxies meet, and these collisions are violent and spectacular. The interstellar gas from both galaxies collides at tremendous speeds, compressing, heating up, creating shock waves that travel through the clouds like cosmic thunder. And from these violent gas collisions, something extraordinary is born. intense star-forming regions called starbursts. These are areas where stars are being born at phenomenal rates, much faster than in normal galaxies. It's as if the collision awakens the creative potential of the gas, triggering an explosion of star formation. Some starburst galaxies are so productive that they form stars 1,000 times faster than the Milky Way. 1,000 times. Imagine, in a single year, these galaxies can form the equivalent of 1,000 years of star production in the Milky Way. It's an almost incomprehensible rate of starbirth, transforming vast amounts of gas into new stars in the blink of a cosmic eye. And interactions between galaxies can create truly bizarre structures. Certain galaxies possess giant gas tails, structures that extend for hundreds of thousands of light years, created by powerful galactic winds or by material torn away in collisions. These tails can be longer than the galaxy itself, cosmic trails left behind like the wake of a comet. Other galaxies possess visible bridges of stars and gas, literally linking one galaxy to another after a collision or close passage. It's as if the galaxies are holding hands across the void of space, connected by bands of matter that have been torn and stretched between them by gravity. They are temporary monuments to gravitational encounters, structures that will eventually disperse or be reabsorbed, but which for now bear witness to the violent dance between galactic titans. But there is a fundamental mystery about galaxies that has puzzled astronomers for decades. Galaxies can spin so fast that, given the amount of visible matter they contain, they should simply disintegrate. Centrifugal forces should rip stars from the edges and scatter them across intergalactic space like water escaping from a rapidly spinning sprinkler. But they don't disintegrate. Why? Because there's something else there, something we can't see. Dark matter acts like an invisible glue, holding galaxies together with its extra gravity. It's a mysterious substance that doesn't interact with light, that can't be seen or touched, but whose presence is absolutely undeniable through its gravitational effects. And here's something that should make you pause and reflect. It's estimated that about 85% of the mass of all galaxies is dark matter, completely invisible to our telescopes. 85%. That means that when we look at a galaxy, we're only seeing the tip of the iceberg, just 15% of what's really there. The bulk of each galaxy is a ghostly halo of dark matter, enveloping the visible stars like an invisible shell. It's a humbling revelation. The galaxies we see, those magnificent structures of light and color that appear in stunning astronomical photographs, are merely tiny islands of luminous matter, floating within much larger oceans of invisible substance. It's as if we were only seeing the lights of a city at night, but couldn't see the buildings, the streets, all the infrastructure that actually supports everything. And this dark matter isn't just passively present. It actively shapes the structure and evolution of galaxies. Its gravity guiding how gas collapses, how stars form, how galaxies interact with each other. It's a silent but fundamental presence, the invisible scaffolding upon which all the visible architecture of the universe is built. And this invisible dark matter not only holds galaxies together individually, it organizes the universe on even larger scales, creating a breathtaking cosmic architecture. Galaxies form groups and superclusters, like cities floating in the cosmic void, connected by invisible bridges of gravity that extend for hundreds of millions of light years. Our own local group, this intimate cosmic neighborhood we call home, actually contains more than 80 galaxies, when we include all the small and faint ones that have been discovered recently. Many of them are so discrete, so dim, that they were detected only in the last few decades through careful astronomical surveys. They are like distant villages around large cities, existing quietly in the shadows of giants like the Milky Way and Andromeda, and in larger structures like the Laniakea supercluster, something fascinating happens. Galaxies don't move randomly, but follow what astronomers call gravitational rivers, invisible paths carved by the distribution of matter and dark matter. They are like ocean currents in space, flows of gravity that guide entire galaxies on journeys that last billions of years. Our Milky Way is in one of these rivers now, flowing gently toward the heart of Laniakea. But why do so many galaxies remain invisible to us? Most dwarf galaxies go completely unnoticed because they shine 1,000 times less brightly than the Milky Way. 1,000 times. Imagine trying to see a lit candle miles away while standing next to a bright spotlight. That's roughly the challenge we face when trying to detect these small, inconspicuous galaxies. And many of these dwarf galaxies have curious destinies. Some orbit larger galaxies just as moons orbit planets, trapped in eternal gravitational orbits. It's a cosmic dance where the small ones circle the large ones, sometimes for trillions of years, always kept at a distance by the same gravity that prevents them from escaping. Our own Milky Way is surrounded by this retinue of companions. It has about 50 known satellite dwarf galaxies orbiting it, each following its own complex orbit through the halo of dark matter around our galaxy. Some are close, like the Magellanic Clouds. Others are hundreds of thousands of light years away, so distant that we can barely detect them. And during close gravitational encounters between galaxies, something extraordinary can happen. Galaxies can literally exchange stars with each other, as if they were kidnapping stars from one another. The gravity of a passing galaxy can rip stars from another, capturing them and incorporating them into its own structure. It's a cosmic theft that happens in slow motion over millions of years. And this is not just theory. It is believed that some stars in the outer halo of the Milky Way, those diffuse regions surrounding the main disk, were born in other galaxies. They were torn from their parent galaxies during ancient encounters and now call the Milky Way home. They are cosmic immigrants, stars that changed galactic citizenship without having a choice in the matter. But here's something many people find surprising. Galaxy collisions don't directly destroy stars. When two galaxies collide, the individual stars pass by each other like ghosts due to the enormous empty space between them. It's like two swarms of bees interpenetrating, where the individual bees rarely touch. But these collisions have a dramatic effect on something else. The gas. When gas clouds from two galaxies collide, they compress violently, and this compression reignites star formation in a spectacular way. It's like blowing on the embers of a nearly extinguished bonfire, suddenly creating intense flames. These collisions can create millions of new stars in explosive bursts, illuminating galaxies with the bluish light of young, hot stars. And the extreme gravitational forces during these collisions can create truly bizarre shapes. Some galaxies have such strange shapes that they defy simple explanations. The ring cartwheel galaxy, for example, looks exactly like that. A cosmic cartwheel with a bright ring of star formation around a central core. It was created by a head-on collision with another galaxy that passed right through the center, creating shock waves that expanded outward like ripples on a lake. Astronomers traditionally classify galaxies into a few basic types: spirals like the Milky Way, ellipticals which are more like balls of stars, irregulars which lack a clear shape, and intermediates which fall between these categories. But the reality is more complicated. Many galaxies simply don't fit neatly into any one clean shape. They are hybrids, unique, each with its own peculiarities resulting from its individual histories of formation and interaction. And there's an elegant way to read a galaxy's history just by looking at its color. A galaxy's color reveals its age and activity. Blue galaxies are young and vibrant, full of massive, hot stars that burn with an intense bluish light. Red galaxies are older and calmer, dominated by old, cool stars that emit reddish light. It's as if galaxies become redder as they age, transitioning from vibrant blue youth to tranquil red old age. And some galaxies age in a particularly dramatic way. Giant elliptical galaxies, often found in the centers of large clusters, can contain trillions of stars, far more than the Milky Way. But here's the paradox. Despite all that mass, they have almost no active star formation. They are like ancient cities that have stopped growing, their stellar populations slowly aging without new generations being born to replace them. At the other end of the spectrum are ultra-dwarf galaxies, so small that they contain only a few thousand stars. They are little more than a large star cluster. It hardly seems fair to call them galaxies, but technically they are. Gravitationally bound star systems, just on a minuscule scale. They are like cosmic villages compared to the megalopolises of the large spirals. And there are galaxies that astronomers affectionately call zombie galaxies. Galaxies that are technically dead. They have no gas, no dust, no new stars being born for billions of years. They are simply populations of old stars, slowly burning through their fuel reserves without any renewal. Eventually, trillions of years in the future, these zombie galaxies will simply dim as their last stars die. So, what kills a galaxy? It is believed that many zombie galaxies have died because of their own central supermassive black holes. When these gravitational monsters actively feed, they can generate winds and jets so powerful that they expel or heat up all the galaxy's internal gas. Without cold gas to collapse and form new stars, the galaxy effectively dies, condemned to only slowly age without renewal. And a galaxy's neighborhood matters profoundly to its destiny. Isolated galaxies, those fortunate or unlucky enough to exist far from close neighbors, evolve much more slowly and peacefully than galaxies in dense clusters. It's like comparing an isolated farm in the countryside to an apartment in the center of a bustling city. Life is simply different. The pace is different. The experiences are different. But perhaps the most fascinating galaxies are those we can barely see. Not because they are faint, but because they are so distant that their light took ages to reach us. Some extremely distant galaxies are seen as they were more than 13 billion years ago, formed shortly after the Big Bang when the universe was only a few 100 million years old. These primordial galaxies are windows into the deep past of the cosmos, showing us what the universe's first stellar cities were like. And recently, the James Webb Space Telescope made unsettling discoveries. It found galaxies so old and so bright that they challenge our current models of universe formation. These galaxies shouldn't exist. They shouldn't be so large, so luminous, so structured so early in cosmic history. But there they are, challenging our theories, forcing us to rethink what we thought we knew about how the first galaxies were born and grew. It's a humbling reminder that the universe still holds secrets, still has surprises waiting for us at the edges of observable space and time. Among the most mysterious galaxies are the dwarf galaxies dominated by dark matter. In some dwarf galaxies, the amount of dark matter is so disproportionately large compared to visible stars that they appear as true cosmic ghosts, almost invisible even to our most powerful telescopes. They are like icebergs, where only the smallest tip emerges above the surface, while immense masses of invisible matter hide below. And our own Milky Way is not alone on its journey through the cosmos. It has more than 50 known satellite galaxies orbiting around it, small cosmic companions held by gravity in orbits that last billions of years. It's as if our galaxy were a giant planet surrounded by a system of moons, except that these moons are entire galaxies, each with millions or billions of stars. And the most famous of these satellites, visible even to the naked eye if you're lucky enough to be in the southern hemisphere, is the Large Magellanic Cloud. It's an irregular dwarf galaxy, a close and bright companion that has fascinated skywatchers for millennia. Indigenous peoples of South America, Africa, and Oceania knew of it long before any telescope existed. But the Large Magellanic Cloud has a dramatic story to tell. It is literally shedding gas as it travels in its orbit around the Milky Way, leaving behind a gigantic trail aptly named the Magellanic Stream. It's as if the galaxy is bleeding, losing some of its substance as the Milky Way's gravity pulls and distorts it. But this loss is not in vain. This trail of gas, stretching for hundreds of thousands of light years, could eventually be captured and used by the Milky Way to form new stars in the future. It's a cosmic recycling cycle, where material from one galaxy feeds star formation in another. Nothing in the universe is wasted. Everything is transformed and reused. And this pattern is common. Galaxies can gain and lose stars over time, like a living ecosystem that breathes, grows, and shrinks, and exchanges material with its surroundings. They are not static and immutable structures, but dynamic cosmic organisms, constantly evolving, constantly changing in response to their interactions with the environment. And the diversity of galaxies is truly impressive. There are galaxies so compact that they concentrate millions of stars in regions smaller than our local stellar neighborhood. They are like super-dense cosmic metropolises, where stars are packed so close to each other that the night sky of any planet there would be a dazzling spectacle of thousands of bright stars. In stark contrast, there are ultra-diffuse galaxies that look like ghostly clouds scattered across space, with very few stars dispersed over vast areas. These galaxies are so faint, so spread out, that they were only recently discovered because they are incredibly difficult to detect. It's like trying to see a transparent cloud against a sky already full of light. And here's something that deeply disturbed astronomers when it was discovered. Some ultra-diffuse galaxies, surprisingly, have almost no dark matter. This completely challenges our cosmological models, because we thought all galaxies needed massive halos of dark matter to form and exist. But these galaxies seem to be exceptions, and nobody knows exactly why. It's yet another cosmic mystery waiting to be solved. The variety of galactic shapes is almost artistic in its diversity. Galaxies can be elegant spirals like the Milky Way, smooth ellipticals like balls of stars, chaotic irregulars without a clear shape, or even perfect rings of stars and gas. It's as if the universe were an artist experimenting with different designs. Each galaxy a unique sculpture shaped by the forces of gravity, rotation, and collision. Spiral galaxies, with their characteristic curved arms, are born from fascinating processes. They form from slow, symmetrical rotations in giant clouds of gas that collapse under their own gravity. As the cloud spins and collapses, it naturally flattens into a disk, and density waves traveling through this disk create the spiral arms we see. Its geometry and physics creating patterns of breathtaking beauty. Elliptical galaxies have more violent histories. They are often the product of multiple galactic mergers, collisions that shattered any original spiral structure and blended everything into smoother, more rounded shapes. They are like cities rebuilt multiple times after disasters, each reconstruction erasing more of the original structure until only a general, smooth shape remains. And gravitational interactions can create truly spectacular structures. Some galaxies possess tidal tails, luminous trails of stars and gas that extend for hundreds of thousands of light years, created by gravitational collisions that ripped material away and hurled it into space. They are like comet trails, but on a galactic scale, temporary monuments to the violence of cosmic encounters. There's something important to understand about galaxy brightness. A galaxy's luminosity doesn't necessarily indicate its age. Young galaxies can shine brightly if they are actively forming stars, while old galaxies can be faint if they have exhausted their gas and stopped creating new stars. Color and star formation rate are much better indicators of age than sheer brightness, and there is a fascinating dichotomy in the behavior of galaxies based on their type. Giant elliptical galaxies rarely create new stars, living like elderly cosmic cities, tranquil and stable, their stellar populations slowly aging without renewal. They are like ancient metropolises that have reached a state of equilibrium, where little change occurs over the ages. Spiral galaxies, on the other hand, are like young metropolises, full of gas, dust, and newborn stars. There is energy, there is activity, there is constant creation. Star-forming regions dot their disks, bright nebulae where new generations of stars are continually born. It is life, it is change, it is evolution in action. And when we look to the frontiers of the observable universe, to galaxies so distant that their light began traveling when the universe was less than 1 billion years old, we see something truly special. These primitive galaxies show us what the cosmos was like even before the abundant formation of heavy elements, when the universe was chemically simpler, dominated by hydrogen and helium left over from the Big Bang. These ancient galaxies are windows into a different era, when the first generations of stars were beginning to forge heavier elements in their cores, when the cosmic recycling of material was just beginning. It's like seeing photographs of the universe's infancy, when everything was younger, simpler, more primitive. And the rate of star formation varies dramatically between galaxies. Some galaxies form stars at such an extreme rate that they are called starbursts, literal explosions of star creation where thousands of stars are born each year. It's a frenetic, unsustainable pace that depletes the available gas in just a few tens of millions of years. But it illuminates the galaxy with intense brightness while it lasts. Other galaxies are the complete opposite, so calm and quiescent that they spend billions of years with almost no star formation activity. They are like cosmic deserts, vast and silent, where little change occurs over the ages. The stars that exist are ancient, slowly burning through their reserves with no new generations being born to replace them when they finally die. And here is a fundamental truth about galaxies. The environment in which a galaxy lives, alone in isolated regions of space, in a group with a few companions, or in a dense swarm with thousands of neighbors, profoundly determines its cosmic destiny. Isolated galaxies evolve slowly and quietly. Galaxies in groups have occasional encounters that can reignite star formation. And galaxies in dense swarms suffer constant interactions, frequent collisions, and can have their gas stripped away by violent processes. It's like comparing people living alone on isolated farms, in small villages, or in dense megacities. The environment changes everything. The experiences are completely different, and the course of life will follow very different paths depending on where you find yourself. In the cosmos, as in life, context matters profoundly. And now, as we approach the end of this cosmic journey, we will delve into the deepest mysteries, the most extreme phenomena that galaxies have to reveal to us. Because every galaxy you see, every spiral or elliptical point of light captured by our telescopes is actually just the tip of something much larger and more mysterious. Each galaxy is enveloped by an invisible halo of dark matter that extends far, far beyond its visible disk of stars. It's as if each galaxy were a shining jewel encased in an immensely larger, ghostly shell. This halo emits no light, absorbs no light, and does not interact with electromagnetic radiation in any way. It is pure gravity, pure invisible mass. And the scale of these halos is truly impressive. This ghostly envelope can be up to 10 times more massive than all the stars in the galaxy combined. Think about it. 90% of a galaxy's mass may be completely invisible, detectable only by the gravitational effects it exerts on the things we can see. It's as if we're only seeing 1/10 of reality, while 9/10 remain hidden in the shadows. And this dark matter is not optional. It's not just an interesting detail. Without it, galaxies would spin so fast that they would simply disintegrate, their stars being hurled into intergalactic space by centrifugal force like water shooting out of a high-speed sprinkler. Dark matter is the invisible glue that holds everything together, the foundation upon which all the visible structure of the universe is built. And dark matter halos don't exist in isolation. Our own Milky Way is immersed in something even grander, a cosmic web, an immense network of filaments of matter and dark matter that connects thousands of other galaxies across unimaginable distances. It's as if the universe were a gigantic spider web, with galaxies caught in its knots and threads. These filaments of the cosmic web can span hundreds of millions of light years, structures so colossal that they defy our ability to visualize them. They are the largest coherent structures in the universe, rivers of matter and gravity flowing through the cosmos, guiding the movement of galaxies over eons. And between these filaments lie enormous voids, regions almost completely devoid of galaxies. These voids are true cosmic deserts, vast expanses of darkness where almost nothing exists. Imagine traveling through one of these voids. You could travel for hundreds of millions of light years without encountering a single galaxy. It's loneliness on a scale that the human mind can barely process. And there is a pattern in the distribution of galaxies. Massive galaxies tend to be located at the intersections of these cosmic filaments, where multiple threads of the web meet. It's like ancient cities built at the crossroads of important trade routes. These meeting points accumulate matter and galaxies, becoming the centers of large galactic clusters. And the activity of star formation in galaxies varies dramatically. Some galaxies are so rich in cold gas, so fertile, that they can form millions of new stars per year. It's an almost incomprehensible rate of creation, where every second dozens of new suns ignite for the first time. These galaxies shine intensely with the bluish light of young, massive stars. Other galaxies are the complete opposite. Appropriately called dead galaxies, they no longer form stars and shine only with the light of old, reddish stars. They are cosmic graveyards, stellar populations slowly aging without renewal, condemned to simply gradually dim over trillions of years until their last stars finally fade away. And the diversity of shapes that galaxies can take is truly impressive. Some have such strange and unique shapes that they defy our simple classifications. There are galaxies shaped like perfect rings, others that look like arches or bridges, some that resemble letters of the alphabet. Each strange shape tells a story of gravitational interactions, of past collisions, of forces that have shaped and reshaped these structures over billions of years. And returning to the companions of the Milky Way, those dwarf galaxies that orbit around giants like our parent galaxy, we have already found more than 50 satellites circling the Milky Way. 50 smaller galaxies, each with its own complex orbit, some close, others distant, all held captive by the gravity of the Milky Way. But the fate of these satellites is often grim. Many of these dwarf galaxies are being slowly swallowed by the Milky Way, torn apart by tidal forces, their stars ripped away and incorporated into the halo of our galaxy. It is a slow but inexorable process, fueling the Milky Way's continued growth over the ages. And this is not a unique event. Similarly, the Milky Way has devoured several smaller galaxies throughout its 13 billion-year history. We can see evidence of this galactic cannibalism in streams of stars in the Milky Way's halo, remnants of galaxies that were torn apart and absorbed. They are like cosmic fossils, evidence of ancient events preserved in the galaxy's current structure. And during these dramatic galactic collisions, something fascinating happens. Although stars rarely collide directly due to the vast empty space between them, clouds of gas collide violently. Gas from one galaxy collides with gas from another at speeds of hundreds of kilometers per second, creating massive shock waves that compress the gas and trigger explosive waves of star formation. And these collisions can have another dramatic effect. They can awaken central black holes that have been dormant, relatively inactive for millions or billions of years. Suddenly, with all this gas being disturbed and channeled toward the center of the galaxy by the violence of the collision, the black hole begins to feed again, devouring matter with absurd intensity and shining like a quasar. And mergers are not rare events in the life of a galaxy. It is estimated that galaxies like the Milky Way have already undergone dozens of mergers over billions of years. Each encounter leaves its mark. Each collision slightly reshapes the structure. Each absorption of a smaller galaxy adds mass and complexity. The galaxies we see today are the accumulated result of countless interactions throughout cosmic history. And this process will continue. The ultimate fate of most galaxies is to collide and merge with others, creating ever larger megagalaxies. In dense clusters of galaxies, this process is constantly happening, with galaxies colliding and merging at an accelerated rate, creating giant elliptical galaxies that dominate their environments. And for our own Milky Way, the future is written in the stars. One day, in approximately 4.5 billion years, it and Andromeda will finally meet. These two great spirals of the local group will collide, merging over hundreds of millions of years into a new giant galaxy that astronomers have already affectionately nicknamed Milkomeda, a fusion of the names Milky Way and Andromeda. And Milkomeda will be impressive. It may have a huge central black hole, the result of the merger of the supermassive black holes from both original galaxies, with a combined mass of billions of suns. It will be a massive elliptical galaxy, very different from the elegant spirals that formed it, but containing all its stars rearranged in new patterns by the gravitational dance of the merger. But even Milkomeda will not be the end of the story. Even after trillions of years, long after our sun has died, long after Earth is just a forgotten memory, galaxies will continue to change, collide, and evolve. The cosmos is always in motion, always transforming, always creating new structures and patterns, even when it seems eternal and immutable to our mortal eyes. It's a profound truth about the universe. Nothing is permanent, not even the largest structures. Everything flows. Everything changes. Everything evolves over timescales that make human existence less than a blink of an eye. And yet, there is beauty in this impermanence. There is meaning in being part of this great cosmic flow, even if only for an infinitesimal moment. So, as you rest now, about to gently drift off to sleep, take this knowledge with you. You are on a planet, orbiting a star, in a galaxy of hundreds of billions of stars, which is immersed in a halo of dark matter 10 times more massive, connected through cosmic filaments to thousands of other galaxies, all dancing through space on journeys that began billions of years ago and will continue for trillions more. You are part of this cosmic dance, this galactic evolution, this story that unfolds on time and space scales that defy comprehension. And there is something simultaneously humbling and profoundly inspiring about that. We are small, yes, but we are part of something immensely larger, connected to everything through gravity, matter, and a shared history that goes back to the Big Bang itself. The galaxies will continue their eternal dance long after we are gone. They will collide, merge, be born, and die through unimaginable ages. And perhaps somewhere in one of those countless galaxies, other beings are also looking up, contemplating the same questions, marveling at the same vastness, feeling the same connection to the cosmos. For now, it's time to rest. Close your eyes, breathe deeply, and let your consciousness drift gently towards dreams. You have traveled through billions of light years on this journey, explored profound mysteries, contemplated structures of unimaginable scale. It's time to let all of that settle gently in your mind as you drift off to sleep. Good night, Cosmic Traveler. May your dreams be as vast as the universe, as deep as the mysteries of the galaxies, and as peaceful as the void between the stars. The cosmos will continue its eternal dance while you rest, and tomorrow, when you awaken, the galaxies will still be there, silently spinning through the darkness, waiting to reveal more of their secrets to those curious enough to seek them. Sleep well, under the invisible stars above you, knowing that you are part of something infinitely bigger and more wonderful than any of us can fully imagine.